Here we go, precipitation reactions. Make sure you have a copy of a solubility rules list with you. It will make your life a lot easier. Reactions of solutions, two things you needed to know. First, we need to know the type of reaction that it is. The second thing is the amount. Well, we already did that. We've already looked at molarity. So now we need to look at the type of reaction. So now we're going to look at precipitation reactions, acid-base reactions, and redox reactions. But first, let's start with precipitation. If you recall, this is a precipitation reaction. It's called a precipitate. And I know it doesn't look like a solid, but if we were to filter it out, let it dry, you could see more clearly that it is a solid. It's just the grains are like as fine as the grains you would find in, say, powder. Precipitates. Here's a classic precipitation reaction. So we have copper 2 sulfate in solution. It's blue, it's pretty. We're going to add to that sodium hydroxide in solution. And then they're going to play wife swap, double displacement, swap the ions. That's the key, swap the ions. So we end up with copper 2 hydroxide, which is your solid, and sodium sulfate, which is still sodium ions in solution. The only thing left to do now is balance this equation. Let's see, 1 copper, 1 copper, 1 sulfate, 1 sulfate, 1 sodium, 2. Oh, well, we should put a 2 here. 2. And now we have 2 hydroxides. So some things you need to know. First off, you're going to need to know how to find these, which I expect you to be able to do. Know their charges, swap the ions, balance the equation, and identify the solid. That's all you have to do. Let's take another look. Barium nitrate plus potassium chromate. So in solution, barium nitrate is going to break apart into individual ions. We have barium ions, we have nitrate ions, we have potassium ions, and we have chromate ions. So when we swap them out, we end up with those. Now, what about this 2? Do I care about that when it comes to the ions? No, I don't, because that 2 only is required for nitrate when it hooks up with barium. But to obey the rules of balancing, I do need to still have 2 nitrates. So I'm going to put a 2 here. Now we're balanced. The question is, who is going to form the precipitate? Yes, this is a double displacement reaction because barium broke up with nitrate and now it's hooked up with chromate. Potassium is now left taking out nitrate. The next question after you do the double displacement is who makes the precipitates? Well, if you recall, according to the solubility rules, potassium always soluble in water, nitrates are always soluble in water, and barium chromate, well, that is insoluble. So that is your precipitate. Couple more vocab words that you really should know on here. I'm going to erase that ink because it's kind of in the way. So there's your precipitate, the barium chromate. These guys that aren't doing anything except watching the chemical reaction between barium and chromate, these guys are called spectator ions because they just sort of spectate. They watch the reaction. Now there are 2 things you need to know. The word soluble and insoluble. The word soluble means dissolves in water. Dissolves in water. You need to know dissolves in water. Pardon me while the door slams. Dissolves in water. And then the other vocab word you need to know is insoluble. And insoluble means it does not dissolve in water. To ask you to memorize the solubility rules. Somebody in your future might. You will be allowed to use the solubility list I handed out, but you should know always soluble, NAG, SAG, and insolubles, PMS. More vocab words. A molecular equation is the complete equation that shows all of the molecules, it's balanced, it shows all of the species. So a molecular equation for this one, sometimes I like to jot off to the side. So here we have silver, and we have nitrate ions, and we have sodium ions, and we have chlorine ions. Now I can play the double displacement game. See, silver broke up with nitrate, now it's going to hook up with chlorine. So we end up with AgCl, and sodium is going to hook up with nitrate. I should write sodium, NO3. Now the next question is it balanced? Oh, yeah, that's easy. Put the states of matter in. That one's dissolved. No, it's not. Got carried away right there. Erase that one. Silver chloride is insoluble. See, chlorides are always soluble, except when chlorine is hooked with PMS, lead, mercury, or silver. All right, anyway, sodium nitrate, this one's always soluble. That's it. You have a complete molecular equation. Now, a complete ionic equation shows all of the ions that exist in the solution. Plus, if you have something that's not an ion, you have to show that too. So it's basically describing what's really happening in the solution. For example, let's take a look at barium chloride. So the formula for barium chloride would be written BaCl2, and it is aqueous. It's dissolved in water. But the complete ionic equation shows what's really happening in the water. So we have barium ions and we have chlorine ions. Over here, I have sodium sulfate, so Na2SO4, aqueous. The molecular equation would show that. But that's not what's really happening in the solution. That's what's happening in the solution. When I mix these two together, over here in this middle beaker, I need to show what's actually going on at the end. Sodium ions and chlorine ions are spectators. They don't play the chemistry game. The barium sulfates are precipitate. That needs to be shown as a precipitate. So we're going to include the spectator ions because that's really there in the solution. And the barium sulfate needs to be shown as a solid. Again, a complete ionic equation is also balanced. When writing a complete ionic equation, it's a really good idea to start off with a balanced chemical equation. So let's do that. Copper 2 sulfate looks like this, CuSO4 plus sodium hydroxide. And that's going to yield, it told us, copper hydroxide, and I know that's copper 2, so CuOH2 solid, plus sodium sulfate, aqueous. We need to balance it. Now, to write the complete ionic, all you need to do is break apart those things that appear as ions. So the copper sulfate should look like this. The sodium hydroxide will look like this. Maybe, if I can write. Then the copper hydroxide stays together because it's really together in the solution. But the sodiums are apart and sulfate is apart. And if you're balanced, well, then you're done. The net ionic equation, remember, just shows the things that actually play the chemistry games. So the only species here that played chemistry games are the barium and the sulfate, because that's the only thing that made barium sulfate. So this would be your net ionic equation for that reaction. For this one, you already have a molecular, you already have a complete. So for extra points, show me your net. Up next, we're going to do precipitation reactions with stoichiometry.